Question is, velocity time graph of a metro train of mass 8000 kg between two stations is shown in the given figure. Answer the following questions. The first part is, calculate the force for the first 5 seconds of its journey. The second part is, calculate the force for the last 10 seconds of its journey. And the last part is, for which time no net force is acting on the metro train and why. So this is the velocity time graph, and let us solve these parts one by one. So in the first part, we have to find the force in the first 5 seconds. So in the first 5 seconds, you can see in this diagram, the initial velocity is 0 meter per second and the final velocity is 20 meter per second. So u is equal to 0 meter per second and v is equal to 20 meter per second, and the time interval is 5 seconds. So the acceleration is change in velocity divided by time interval. So acceleration comes out to be 4 meter per second square. So as we know from the second law of motion, the force F is equal to ma, and if we substitute the values, m to be 8000 kg, that is the mass of the metro, and a is 4 meter per second square, the force comes out to be 32,000 Newton in the first case. Now in the second case, we have to find force in the last 10 seconds. So in the last 10 seconds, you can see in this diagram, the initial velocity is 20 meter per second and the final velocity is 0 meter per second. That is, u is equal to 20 meter per second and v is equal to 0 meter per second, and the time interval is 10 seconds. So the acceleration is change in velocity divided by time, and acceleration comes out to be minus 2 meter per second square, minus because this is retardation. So force is equal to ma. So force comes out to be minus 16,000 newtons, and minus it is because due to retardation. And the last part, which states that in which part there is no net force acting on the train. So from time 5 seconds to 40 seconds, there is no force acting on the train, as there is no change in velocity in this part of the graph. As there is no change in the velocity, there is no force acting on the train. I hope it is clear to you. Thank you.